Welcome to this tutorial on the valve fitting functionality in Insight. In this video, we'll step you through the process of creating a valve from your experimental data. This feature, found within the valve utility, offers a powerful and user-friendly solution for creating, viewing, editing, and storing valves. We will use regression analysis to fit the generalized AICD equation using 10 coefficients to your data points. We'll also show you how to properly format test data in an Excel spreadsheet for seamless integration into Insight. You will learn how to utilize the plotting functionality to examine valve performance. And finally, we'll save valve information to the database, making it ready for use in Insight's multi-run regression tools before being incorporated into a reservoir simulator. Let's go ahead and get started. With Insight open, we will go to Utilities tab and select Valve Utility. We can then go to the Match Valve to Data tab. This window is broken down into three sections: Data Post-Processing, Regression Parameters, and Regression Post-Processing. Before we input our data, I'd like to show you how to format your Excel file to quickly be able to import it. Open up your Excel file containing the valve data, and we'll define our columns with the following heading: DP, Q, oil ratio, gas ratio, water ratio, oil density, gas density, water density, oil viscosity, gas viscosity, water viscosity, and weight. Now that we have correctly defined our heading, it's very simple to read the data into Insight. Let's exit out of this spreadsheet and open Insight Valve Utility back up. Click on the Import Experimental Data button. Locate the file containing your test data and click Open. The Data Import wizard will appear. First, select the name of the spreadsheet containing your experimental data points. Next, ensure the correct column names are assigned to each variable. As you can see, Insight has already identified the appropriate columns for us. However, if any adjustments are necessary, simply choose the variable name from the drop-down menu and modify it as needed. Set the number of decimal points for the imported data and click Finish. In the left table, you can see all of the imported data from our spreadsheet. On the right-hand side, there is a three-dimensional plot of the weights of each data point and a DP plot, or delta pressure. By examining the weights plot, you can see that all of the data points have equal weighting. This means that when we perform our regression, each point will have equal impact on the coefficients that will be generated. For now, we'll leave the weighting as is and proceed with generating our valve. We will change the name of our regression to Example Valve. And set our calibration density to 1000 kilograms per meters cubed. Keep our calibration viscosity to 1 centipoise, and we'll keep our fitting variable as flow rate. Next, you will select a folder where the regression will be saved. We can also choose to freeze certain parameters if that is desired. We will now run the regression, and a regression status bar will appear at the top of the screen to track the progress. The regression is now complete, and you can select it from the drop-down menu. Here you can view all 10 coefficients generated during the regression. Select your regression from the drop-down menu to inspect how well our generated valve aligns with our test data. As we can see, the surface of our valve accurately represents the test data. Take note of the significantly higher noise levels in the two-phase data compared to the single-phase data. This observation may make it preferable to assign greater weight to the single-phase data over the two-phase data. Another reason to prioritize single-phase data accuracy is its likelihood of being more prevalent in your reservoir simulator. I will demonstrate how to weigh the single-phase data in a separate video. We will save this valve to our database, where it is ready to be used further in Insight. This concludes this tutorial, and we hope that you found it useful. Thank you for watching.